In this lesson, we'll rough and finish a basic part from the bottom. After completing this lesson, you'll be able to create a contour operation with the ramp option, create drilling and tapping toolpaths, and modify toolpath order to reduce non-cutting feed times. Let's carry on with the file from our previous example, and let's take a look at creating our secondary setup. In this case, we're going to be machining the backside, which are slots and tapped holes. The first thing that I want to do is rename my setup. We're going to call this Soft Jaw Setup 1. Also note that we can drag and drop the setups inside of our setups folder just like we can with toolpaths within a setup. So now we have our soft jaw setup, our coordinate system is set, our XYZ is in the upper left hand corner of this part. The next thing that we need to do is we need to start machining the backside of our part. To do this, I first want to go to Inspect, and I want to measure some of the geometry we're working with. So if we take a look at this, note that I have secondary units turned on to millimeters. Our diameter is 0.402, and that equates to a 10.2 millimeter. If we were looking at a tap chart, we would see that this means it's a M12 by 1.75 thread. We also want to take a look at the radius value in the corners of our slots. You can see the radius value is 0.197 or the diameter is 0.394. This means that we could likely bring a 3/8 tool in to cut these slots, but in reality we would want something a little bit smaller so we could get in and do a final cut or a finishing pass. So now that we have that information, it's always a good idea to place that as a comment in the design file. So if we expand the comments, you can see that I've already placed some of this information in this file. And it's a good way that we can reference this, especially if we're creating a toolpath on the fly and we don't want to go back into Inspect and essentially cancel out of that toolpath. So now we have this information in here, we're going to go in and start creating our first toolpath. Remember, we're working with our stock that is exactly the size of our final part. When you're creating soft jaws, it's not uncommon to simply have the stock laying around that matches this, and even have the holes tapped and slots on the bottom already created. Since we're talking about multiple setups, we're going to go through the process of creating these operations and the flip, but we're not going to be talking about finishing the outside of the part. From here, we're going to go into 2D and select 2D contour. And for the tool, I'm going to bring in a 1/4 inch end mill. So I'm going to go into my samples library. I'm going to filter out by flat. And then I want to take a look in the aluminum section and grab a flat 1/4 inch end mill. Notice it brings us in as tool number 5. If we need to modify this, we can right click on it, edit the tool, and we can change its tool number. In this case, I'm going to make it tool number 10, and then say OK. Now we want to select our geometry. Again, it's important to select the chain at the depth that you want to cut. In this case, all the chains are at the same depth, and this is exactly where we want to cut, so we're making sure that we select those chains. We don't need to worry about tabs or rest machining or any of these other options. We do want to go into our passes section and turn on multiple finishing passes. Because we're not going to be roughing these, we're going to go into our linking parameters and we're going to turn on ramp. We're going to allow it to ramp down at 2 degrees to create these cuts. So now let's simulate this and take a look at the toolpath. So the tool is ramping down as it follows the contour for its first cutting pass. Then it's going to go back and it's going to do a finish pass at the final depth. It's going to repeat this for each of the slots. And then it's going to work its way around to the other one. Note the order in which these happened is not the most efficient. So we can change the way that they're ordered, or we can keep it in mind when we start selecting holes to be drilled and tapped. From here, we're going to go to drilling. We're going to change the tool, remembering that we need to use a drill bit that is either 10.2 millimeters or is 0.4016. So we're going to select drill, and if we want to, we can filter out the dimensions. For example, we can set the minimum diameter value to 0.4, and we can set the maximum diameter value to 0.425, and that should give us a wide enough range to see what we have available. So you can see here in the samples inch aluminum, we have a 0.404, which is a Y. And notice that that's a little bit too large for us. We're looking for a 0.4016 or a 402. And if we scroll down and we look for a metric section, you see that we have a 10.2 millimeter drill. So we're going to select the 10.2, and we're going to say OK. And then we want to go in and select our geometry. Remember that we can set up a diameter range, and we can go between, in this case we'll say 0.2 to 0.425, and it'll select all those holes for us. So again, keep in mind the order in which the slots happened. It went from here to the right, back to the left, and then it's trying to start the order by going to this bottom right hand corner, which means that the tool is going to have to move all the way across the part again. If we reverse the order, that means it's going to start over here on the left hand side, which is where we're ending our slot operation. By default, it's going to pick up on the depth of the hole, so we don't have to worry about the depth of cut, but we do want to talk about the cycle. We're going to use chip breaking, which is a partial retract operation, and the pecking depth is going to be based on the tool diameter, in this case 0.1. We're going to say OK, and now we've created the drilling operation. The next thing that we need to do is we need to tap these holes. So I'm going to right click and duplicate this toolpath. Then I'm going to modify the duplicate, change my tool selection, I'm going to remove the diameter, and I'm going to filter type by right hand tap. Then we want to take a look at the taps that match. We're going to go into our samples library, and remember we're looking for a metric tap. So as we look through these, we'll have to go down into the metric section, and we're looking for an M12 by 1.75. Once we have this, we'll have to go to our cycle and make sure that we change this to tapping. Because we didn't create this operation new, it's not going to pull that perimeter in from the tap. So if you simply duplicate a drilling operation, it's going to try to use a peck drilling operation with a tap, and that's obviously not going to end well. I am going to modify my heights because I don't want to go all the way to the bottom of the hole that we drilled. I'm going to add a small amount of offset. In this case, I'm going to say 0.03. And the positive value will pull it back up in the Z direction. So if we take a look at our coordinate system, Z plus is pointing up. So a positive value is going to move up in the Z coordinate system, where a negative value would go deeper into the part. So from here we've created a slot contour, we've created a drilling operation, and then a tapping operation. So let's select this and let's go ahead and simulate it. I'm going to turn off our toolpaths. I'm going to speed this up, making sure that we cut all the geometry we need on the backside of our part. So it does a drilling operation, then it goes back to the tapping. Now keep in mind the order of operations is important as well. So if we go to our geometry section and we turn off reverse order, now what we're doing is we're starting the tapping operation at the last hole that was drilled. So the drill starts over here on the left hand side, works its way around, and ends on the bottom right. And if we reverse the order, the tap will start on the bottom right and work its way back around. Small changes like this can make a big difference, especially on larger parts. So always keep in mind where your tool is either starting or ending the operations and how we can actually modify the parameters to make that work a little bit better for us. At this point, let's go ahead and save this file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.